Hello, my name is Andy Oscom, and this is a brief presentation showing the optimized results from analysis and re-engineering of the investment casting process. The process was observed at a small Pennsylvania business. First, let me clue you in by giving a brief overview of the major steps involved in the current process. It's a very old metal casting method with roots back to the Egyptians. To start the process, a pattern is formed by injecting wax into a die. Once the injected wax is set up, it's removed and assembled onto a wax sprue system, which will eventually form a mold. Once the wax assembly is complete, it's dipped into ceramic slurry, drained, coated with ceramic stucco, and dried. This step is repeated several times depending upon how much metal the mold needs to hold downstream in the process. After the ceramic layering is completed, all wax, both pattern and sprue, is melted out of the ceramic shell. This empty ceramic shell will in turn receive the molten metal. The molds are grouped by like alloys and fired. Metal is then melted and poured into the mold. After pouring, the mold is allowed to cool and the ceramic mold material is knocked off. At this stage, we can now see that what we had in wax is exactly what is now metal. With the bulk of ceramic mold material removed, the whole thing is shot blasted clean and the parts are cut from the sprue system. Following cutoff, the castings have the gating witness ground off. This is a stub of metal left from the cutoff operation. Immediately after the gate grinding operation, castings are visually inspected, marked for traceability, and any rework is performed, which most usually involves some degree of weld repair. From here, the castings go to an outside subcontractor for heat treatment. Once back from heat treatment, parts are blasted to remove heat treat scale. They are then sent through a final inspection and finally shipped to the customer. A current state flowchart was developed, and all told the process involved 38 steps, totaling 13,943 minutes, or just about 10 days. From this chart, I constructed the process analysis worksheet and broke out all the value-add and non-value-add steps, as well as identified what waste category the non-value-added steps fell into. Several numbers of importance were generated, including 38 total process steps, 14 of which were value-add at 36.8% of all steps, a total value-add time which was 309 minutes, and work efficiency coming in at 2.2%. With that information segregated, I developed a new flowchart showing the current state steps as value-add or non-value-add. My next focus was on the re-engineering the process, and I focused primarily on reducing or eliminating as much of the non-value-add components as possible. I accomplished this by researching current technology available, utilized sound lean practices, and good old common sense. I generated an optimized process analysis worksheet detailing what steps were taken out and what steps were reduced in time. This saw the total process time drop to 4,238 minutes, total steps dropped to 26. This in turn raised the percent of value-add steps up to 53.6%, and optimized work efficiency increased to 7.3%. Then I generated a third and final flowchart detailing the optimized process. To wrap it up, I calculated the process improvement efficiency using the total process times from both the current and optimized states. The PEI landed at 69.6%. So basically, a 70% improvement by focusing only on waste reduction within the current process. Thanks for watching.